welcome back to my channel. It's a cool electric. Today we see the three-phase circuit, especially the three-phase circuit introduction. What is the basic things, how the three-phase power is generated, and which things are inside the three-phase circuit basically. Let us start. A single-phase system has its own limitation, therefore it's replaced by the polyphase system. A polyphase system is a combination of several single-phase voltages having the same magnitude and the frequency but displaced from one to another by equal angle, which depends upon the number of phases. So there are three phases in the three-phase circuit and each phase apart 120 degree. So how it's calculated? Here is the electrical displacement. The total electrical degree is 360 and the number of phases, suppose the three number of phases is there, so 360 divided by 3 phases, then 120 degree each apart from another phase. So if suppose you want to say that there are three phases R, Y and B, so each phase is apart 120 degree from another. A supply system is said to be symmetrical when the several voltages of the same frequency have the equal magnitude and are displaced from another by equal angles. So R, Y, B having the equal magnitude and displace each other from 120 degrees, and you can say that is the symmetrical. Okay, a three-phase system is said to be symmetrical when the line voltage are equal magnitude and are displaced from one another by 120 angle. We already know that. So what is the advantage? What is the advantage of three-phase system and why we are not using a single-phase system? That is the single phase limitation and the advantage of three-phase system. Let us see. Here is the power delivered in the three-phase system is constant while the power delivered in the single phase system is pulsating. It is more economical. Three-phase system is more economical because it requires the lesser amount of conducting material as compared to the single phase system. Three-phase machine gives more output as compared to the single-phase machine of the same size. So when we talk about the single-phase machine and three-phase machine, then three-phase machine must deliver the more output. Okay, three-phase machine have the uniform torque, whereas in single-phase machine have the pulsating or the non-uniform torque. Three-phase motor have a more torque as compared to single-phase motor, but obvious. The domestic power and the industrial power or the commercial power can be supplied from the same source. Okay, so the three phase is better. And in three phase system the voltage regulation is better. What is the voltage regulation? Suppose we required the 240 volt AC, then it is nearer to the 240, then it's a more voltage regulation. So the voltage is regulated near to the required voltage. So the regulation is higher if voltage is near to the reference voltage. Another, three-phase motor are self-starting, whereas single-phase motor are not self-starting. Power factor. When we talk about the power factor, the three-phase machine having the higher power factor than the single-phase machine. Three-phase system is the more reliable and the more capable than the single phase. It is possible to produce rotating magnetic field with a stationary coil by using the three-phase system. So the three-phase motor are self-starting, where single-phase is not. Single-phase supply is obtained from three-phase supply. We know that in RYB, one neutral is there, the voltage across the neutral and any phase, that is the single phase source, that is the single phase supply, and that is obtained from the three phase. Okay, but from the single phase, three single phase, you cannot obtain the three phase supply. because the each phase is 120 apart. Let us see how the three-phase power is produced. Here is the three different coil. One, that is the R, another, that is the Y, and the last one, that is the B. So R angle between the R and Y, that is here is the 120, and angle between the Y and B, that is again 120. Let us see. So here is the field from N to S, and that is cut by the coil. First the R phase, then when the coil is rotated, that time just you can see the R phase shown the red. This is the peak, this is the peak for the Y phase, this is the peak for the B phase. Okay, so from 0 degree the minimum flux is linked with the coil R, and from that here the maximum flux is linked with the coil. That time the maximum EMF is produced by this coil, and same for the different two coil, Y phase and B phase. Okay, all these three generated voltage known as the ER, EY and E base. These all are 120 apart from each. So if you want to give equation for this voltage, normally in single phase, that is the V equal to Vm sin omega t. So that is the same reference equation is there, ER equal to Em sin omega t. We check R as a reference. So what is the angle between R and Y? That is the 120 degree. So here the minus 120, and here is the minus 240. R phase as a reference. So this is for the Y phase and this is for the B phase. So three-phase voltage can be represented in the polar form. This is the polar form. When the amplitude and angle is there, then you can say that is the polar form. Here is the representation on x-axis. Just we take as a reference ER. You can also take is on the y-axis. Okay, so ER, EY and EB. So the ER is front as a reference, 120 leg, another 120 leg, then just you can obtain the EB 240 apart from this ER, and the EY is 120 apart from the ER. So here is minus 120 and here is minus 240. So just in case of the balanced three-phase voltages, just you add all these R phase, Y phase and B phase in this is the polar form. So just you have to convert in the rectangular form. So 1 at angle 0, that is converted in the rectangular, 1 at angle minus 120 here, and 1 at angle, so this is the plus 120. So if you want to write minus 240, that is equivalent as the plus 120. Okay, so the totalize all these three, you will get 0. So the three-phase voltage addition resultant voltage is 0. In case of single phase, for the whole cycle the resultant voltage is also 0, but RMS is not 0. Okay, so this is the average voltage. Okay, so here is the vector sum of this all three voltages is 0. So this is up to the now. Thank you very much.